Alright, let's mathematize. Welcome to Exquisite Academy. In our last video, we talked about variable separable differential equation. In today's video, we are going to look at first order differential homogeneous differential equation. We're going to look at first order homogeneous differential equation. Now, the first thing to know is how do you know if a differential equation of order 1 is homogeneous? To know this, you have to look for the sum of the powers of the two variables in each term. Okay, let's look at this example now. The power of y here is 1, the power of x here is 1, the power of x here is 2, the power of y here is 1. So since the power of x and y is 1, it means that this is homogeneous. If we have 3x squared plus 4yx all over 3xy plus 4y cubed over 3x. Now this is x squared, y plus yx, the power of y is 1, the power of x is 1, so the sum of the powers is 2. The power of x and y here is, the sum of their powers is 2. Now the power of x here is 3, the power of y here is 3, and the power of x here is minus 1. So the sum of this power is 2. So because the sum of all the powers of x and y is 2, we say this is homogeneous. This is a first order homogeneous differential equation. This is a first order homogeneous differential equation of degree 2. Now that sum of the powers that you have gotten is what we call the degree of that homogeneous equation. That's not the degree of the differential equation. The degree of this differential equation is 1 and the order is 1. But that does not, but the degree of this homogeneous differential equation is what we call 2. Now let's quickly solve that. Set dy over dx is equals to that. Now anytime you observe that a differential equation is homogeneous, the first thing you must do is to let a variable, let's say that variable is v, equals to y over x. Now if v is equals to y over x, it implies that y is equals to vx. Now if I differentiate each of these variables, I will have dy, and I'll have, if I differentiate v, I will have x dv, plus if I differentiate x, I will have v dx. Now if I divide everything by dx, I'll be left with dy over dx is equals to x dv over dx plus v. Now because I have said let v equals to y over x such that y is equals to vx, our dy over dx becomes x dv over dx plus v. So anywhere I see dy over dx, I replace it with x dv over dx plus v. And anywhere I see y, I'll replace it with vx. So let me quickly do that. Dy over dx has been replaced with x dv over dx plus v. Then my y has been replaced with vx. So we have 4vx minus 3x all over 2x minus vx. Now if you observe there's x here, so x is common. X is also common here. Now this is what homogeneous differential equation does. Because we know that the sum of the powers of x and y are equal, we know that anytime we factor out those x out, it will also cancel. So anytime you have an homogeneous first order differential equation, one thing that must always cancel out is the x variable. It must always go out of the equation such that you'll be left with only a function of v. So the aim of an homogeneous first order differential equation is to convert this, which is not variable separable, to look like variable separable. So if you observe now, we have x dv over dx plus v is equals to 4v minus 3 all over 2 minus v. Now we have converted something that is not a variable separable differential equation to look like variable separable differential equation, because this is a function of v, and if I take this v to this side, I will have minus v here, which is also a function of v, and this is a function of x. And in our video about differential equations, variable separable, we said anytime we have a function of v and a function of x separately, that it is called variable separable differential equation. So if I take this one here, I will have 2 minus v, then everything like this. So x dv over dx becomes 4v. 4v minus 2v is 2v. Minus v times minus v is v squared. Plus that 2v we had. Then minus 3 all over 2v. Now I can factorize this expression at the numerator. I will have to think of two numbers such that their product is minus 3 and their sum is 2. That two numbers is actually 3 and minus 1. Minus 3 times minus 1 is minus 3. 3 minus 1 is 2v. So if I factor out, I will have v plus 3 bracket v minus 1 all over 2 minus v. So this will be if we factorize this is what we get. So our x dv is equals to that. Now if I take this to this side, I will have 2 minus v x dv over dx is equals to v plus 3 bracket v minus 1. So this is also a function of v, so I will have to take this function of v back to this point. So we have 2 minus v all over v plus 3 v minus 1 equals to dx. I took this dx to this side. Then I'll take this x downward. So this is what we have. Now in order for me to solve this, I will have to see this. I'll take this integral by partial fraction. So I have to simplify this form to be partial fractions. So how do I do that? I'll let 2 minus v all over v plus 3 v minus 1 to be equal to a over v plus 3 plus b over v minus 1. So 2 minus v, if I multiply through by everything here, is a bracket v minus 1 plus b bracket v plus 3. Now, if I want to use cover up method, now for what value of v would this expression be 0? If v is minus 3, we have minus 3 plus 3, which is 0. 0 times b is 0. So the b is gone. We are left with a. So let's make v minus 3. Minus 3, 2 minus minus 3 is 2 plus 3. Since we said v is minus 3, so 2 minus minus 3 is actually 2 plus 3. That's 5. So we have 5 equals to minus 3 minus 1 is minus 4. So we have minus 4a. So our a becomes minus 5 over 4. This becomes our a. Then for what value of v will this expression be 0 so that we can get b? If v is 1, v minus 1 is 0. So this part is 0. We can get our b. 2 minus 1 is 1. 1 plus 3 is 4. So we have 1 is equals to 4b. Then our b is equals to 1 over 4. So instead of writing this as this, we can change it to this. So we have, if I integrate both sides, I will have the integral of a over v plus 3, where a is minus 5 over 4, bracket v plus 3, then plus our b, which is 1 over 4, bracket v minus 1, dv, everything dv, equals to our dx over integral of dx all over x. So if I integrate this, I will have minus 5 over 4 ln v plus 3. If I integrate this, I will have plus 1 over 4 ln v minus 1. And if I integrate 1 over x, I will have ln x plus, now I want this, everything has natural log. So instead of me writing a constant c, I will just change it to natural log so that everything will be in line. Now if I multiply through by 4, I will have minus 5 ln v plus 3 plus ln v minus 1 equals to 4 ln x plus, let me just change this to, if I multiply this by 4 again, I'll still have another constant. Let me change it to ln b. Let me say that constant is ln b, where b is a raised to power 4. So we have ln v plus 3 raised to power minus 5 plus ln v minus 1 equals to ln b x raised to power 4. Now this is x raised to power 4, then times this b. Now I cannot multiply these two from our normal rules in logarithm. That when you have log something plus log another thing, the product of them, and you take one log. So we have ln v minus 1. Since this power is negative, we'll bring it down. V plus 3 raised to power 5 is equals to ln bx raised to power 4. Now this natural log can cancel out now easily. So we are left with v minus 1 all over v plus 3 raised to power 5 equals to bx raised to power 4. We are not done. Remember that we said that our v is equals to y over x. So anywhere I see v, I'll change it to y over x. So recall, v is equal to y over x. So anywhere I see v, I change it to y over x. I will have y over x minus 1 all over y over x plus 3 raised to power 5 equals to bx raised to power 4. Now there is x here. If I take this x here, simplify it, I will have y minus x all over x, then divided by this expression here, which is y plus 3x all over x, then everything raised to power 5 equals to bx raised to power 4. This is the same thing as y minus x all over x times x raised to power 5 all over y plus 3x raised to power 5 equals to bx raised to power 4. Now this x raised to power 5 divided by x is x raised to power 4. And this x raised to power 4 here can cancel out with this x raised to power 4. So we are left with a constant equal this. So we have y minus x all over y plus 3x raised to power 5 equals b. So if I take this one here, I will have y minus x is equals to b bracket y plus 3x raised to power 5. Now when I take this x to this side, I will have y is equals to a constant y plus 3x raised to power 5 plus x. So this is the equation. But remember they said that when x is 0, our y is 1. So anywhere I see x, I'm going to put 0. And anywhere I see y, I'm going to put 1. The aim there is to get this constant b. So y is 1, x is 0. So we have 1 raised to power 5 times b plus 0. And our y is 1. So we have b plus 0 is equals to 1. Which means that b is equals to 1. So instead of me writing that, I'll just remove it. Suppose b was 2, I'll write 2 here. So this is our equation. So you can also, is a particular solution to that differential equation. We said when we have this constant here, it is the general solution. But when we have a value for this constant, it is a particular solution. Now, if you decide to try this out by differentiating this once, you will observe that you will get to this point where dy over dx is equals to 4y minus 3x all over 2x minus y. You can give it a try because we did in our first video how to obtain a differential equation. So in differentiating this, you will end up having 4y minus 3x all over 2x minus y. So that will be all for this video. We'll talk more about differential equations in our next video. Please subscribe to this YouTube channel and like my videos. If you have any issues with maths, you can send it on the comment section and we'll do a video for you. Thank you very much.